All right, some special products that you will see, some special factoring products that you'll see is difference of two squares. The objective is factor the difference of two squares. You will see stuff like, number 1, x squared plus 0x minus 25. Now the same drill here, same drill as before. You're going to factor, so you will list out your parentheses like so. And you're trying to figure out, hey, what goes here and here? Well, that product should be negative 25. Well, let's list out the options for 25. I know that 1 and 25 multiply, and I know that 5 and 5 multiply to 25. But our goal ultimately is to get a 0 in the middle. Can I get 0 from 1 and 25? Nope. But wait a minute, I can get 0 from 5 and 5, can't I? Absolutely. One needs to be what? The other needs to be what? You guessed it. Plus 5 minus 5. This, ladies and gentlemen, is perfect squares. Difference of perfect squares. And why is it called difference of perfect squares? Well, look. You have 0x in the middle, so the outside and the inside terms cancel each other out. And if you look on the board, 25, 81, 4, 25, those are examples of, you guessed it again, perfect squares. Take a look at number 2. Okay, we need two numbers that multiply to 81, and they need to be polar opposites of each other. What's the square root of 81? Bingo. But one needs to be plus, the other needs to be minus. Okay. Number 3 here, 4x squared plus 0x minus 1. Alright, so what you will notice is you will take the square root of 4, and those numbers will be placed here and here. What's the square root of 4? It's 2. So I can place a 2x and a 2x there. And now the square root of 1, what goes here and here? The square root of this guy. What's the square root of 1? 1 and 1. So in these difference of perfect squares, you will notice that you will have the same, essentially the same factor, but one's positive and one's negative. And that's by design because, again, like I was saying, the middle term must cancel out. So let's try this next one. If you look here, the square root of 25 is 5x. Whoops. It's 5, excuse me. But we put the x on it because it's 5x squared. 25x squared. And then you have the square root of 1, which is 1 and 1. Make one positive, make one negative. Every time. And this only works, again, when there's a 0x in the middle and you're dealing with two perfect squares. Hence, difference of squares. Okay, let's try these ones out. 2x squared minus 9x plus 4. What we will do is we will notice first that they're not difference of perfect squares because there's no 0x in the middle, so we will have to factor these like normal. Normal, the coefficient is 1, but here it's 2, so we're going to have to trial and error this thing. So let's list out all the factors of 2, 1 and 2. Those are my only two options to start off this problem. Where I will have more options is when I have 1 and 4 and 2 and 2, because one of these sets of factors will go here and here. How do I figure it out? Guess. Try 1 and 4. And check. Outside, 8x. Inside, 1x. Can I get a negative 9x from this somehow? Where's this negative 9x coming from? Right here. Can I get a negative 9 from this? Absolutely you could. If you made that negative and this negative, which means 2x times your 4 needs to be negative 8. Well, that can only happen if that term's negative. 1x needs to be negative. Well, that could also only happen if that term is negative. So see, again, we got lucky, but if that didn't work out, if we did the outside times the inside, and it couldn't come out to negative 9x in any circumstance, what you would end up doing is trying a different combination of factors. All right, very good. Let's try number 6, last one. X squared plus 8x plus 12. Well, this coefficient is 1, so we're going to factor like normal. And we will list out factors of 12 that we can use to get us positive 8. We need positive 8 in the middle. So can I get 8 from that? No. Bingo, 2 and 6. And they both shall be positive.